Welcome to the third keynote of the International Conference on Computing, Communication and Learning. So, I request Dr. Balprakash Rao, sir, to introduce Professor Marcin. Sir, please.
Yes, sir. So, good afternoon, Dr. Marcin.
Hello.
Hello. Yeah. So, it's a great pleasure for me to introduce our keynote speaker, who is going to talk us about introducing federated learning to IoT ecosystems. This is a subject in which we should all be deeply interested because it facilitates the training of models in a distributed environment. So, I take this privileged opportunity to introduce Dr. Marcin Paprzycki. So Dr. Marcin Paprzycki received the MS degree from Adam Mickiewicz University, Poland, the PhD degree from Southern Methodist University, Dallas, Texas, and Doctor of Science degree from Bulgarian Academy of Science, Sofia, Bulgaria. He is currently working as an associate professor with the Systems Research Institute, Polish Academy of Science. He is a senior member of ACM. He is a senior Fulbright lecturer and IEEE Computer Society Distinguished Visitor. He has contributed to more than 500 publications and he was invited to program committees of more than 800 international conferences. His research interest includes software agents, scalable computing, intelligent systems. So I once again welcome Dr. Marcin Paprzycki to deliver his keynote lecture.
Okay, so first things first, guys, I know that it's a bit late, but to all of you, happy Diwali. I hope that lights will be always with you and will guide you through your path of life towards betterment of society. Happy Diwali. Now, let me share what I'm gonna share my screen. Now I want entire screen. Okay, allow. Okay, now you should see me on me with me and me, you know, the infinite me in the series of screens exactly. Because I am presenting my screen, which has me, which is presenting me. Yeah, it's infinite regress. But I wanted to share this with you so that if you want to find me, you just put my first and last name in Google Scholar and you can find what I have been up to. You can also put my first and last name into Google search, and this is my actual website. So here you can find information about me. You can find my research interest and other things. This information has not been updated, but it will be shortly. Okay. Now, with this, I want to let's start the slideshow. Do you see my first slide?
Yes, Professor. Yes.
Okay, by the way, if somebody can from time to time, and especially with this slide being in the middle, take a screenshot of this slide and other people around it, because I needed to report it to the project, because this presentation is in part supported by the Assist IoT funded project funded by the European Commission. I work at the Systems Research Institute, Polish Academy of Sciences. I also work in a private university in Warsaw, but for the context of this work, the SRIPAS, as we name it, Systems Research Institute, Polish Academy of Sciences, is the right context. And what I want to share with you today is a few reflections on federated learning. I will have introduction for you, and I will also have a little bit more, because I will have also some practical considerations, which I think are much too often not taken into account, but we will get to it. So let's start from distributed machine learning. So let's assume that you have some computational intensive task. And of course, this computation intensive task could be solving some large scale partial differential equations. It could be going on with some other graph algorithm or big matrix operations, but we are particularly interested here in something that is related to artificial intelligence or machine learning, okay? And it's large. Now, the artificial intelligence machine learning can be different. It can be training neural networks, but it could be nature-inspired optimization or data clustering. Doesn't matter what it actually is. But what the observation here is that if you have some large or very large data sets, then if you try to apply some algorithm to solve it on a single computer with even multi-core processor, but it has just one node, this would require substantial amount of time. And I'm not sure what is your experience, but in the worst case scenarios, I have seen my students reporting some machine learning tasks taking them days, 2, 3, 4 days easily. Sometimes it was even a week when the student was doing some image processing with large image base. It was weeks before the solution was delivered. And then the solution was found to be wrong and a new one had to be delivered again. Now, let's assume for a while that you have multiple computing nodes. They can be like network of workstations, it could be cluster computer, it could be supercomputer, doesn't matter. The question that was asked long time ago was how the work can be divided and then combined. So what we want is we want this problem, the algorithm, the problem that we are trying to solve, split. Each part run separately on one of the nodes. Let's name them nodes. And then somehow it has to be combined. Now, combining, this is the cute part that you can combine sometimes. At the end, just work, combine, and you have an answer. Or you may work like this. You work, you combine, then you split, work, combine, split, work, combine, split, work, combine, split, until some kind of a solution is reached. And I am trying definitely to be vague here because it is what is important is to be able to split and combine, and it doesn't matter this much what are the details of this process. Now, a classic example that I like very much was doctoral work of Eric Cantupaz, who worked at the University of Illinois in Urbana-Champaign, and in January 2000, he presented work on multiple instances of genetic algorithms that run on separate nodes, and from time to time they exchange genetic material. Later on, it became known as island version of evolutionary computing. This is his PhD dissertation, and he was using machines, supercomputers of the time from National Center for Supercomputer Applications at University of Illinois in Urbana-Champaign. There was a big supercomputing center at UC. So this is what I'm talking about when I talk about distributed machine learning or distributed artificial intelligence. Okay. Now, this is a well-researched area. So you can see here, by the way, Eric was not the first one. Okay. So January 2000, is I am using this one just because I like the island version of evolutionary or genetic computing, but it is well studied, and parallel computing is also well studied. There is more than 40 years of development of parallel computing. I was doing, well, not 40 years yet, but more than 30 years ago, I was doing my PhD with parallel computers. So if anybody is interested, here is a link to work by Verbeke, Volting, Katzi, Kloppenburg, Verbelen, and Rellmeyer from archive from 2019, which is a survey. Okay, so it's a very nice survey that has plenty of information. However, one of the things that if you start looking into the research that you will find in the area of distributed machine learning, DML, is that there is, in majority of cases, this assumption that there is a single data owner, which means it's a person. It can be a company. Doesn't matter. Okay, it's just that this one owner has all the data. And this means that this owner, let's say user, but user can be a company, can split the data, but remains in full control over all of this data. And then, of course, you can take some open source public data sets and include to improve results, to get better prediction, and so on. But still, it is single owner. And this, by the way, having cloud computing or no cloud computing doesn't matter, okay? Because cloud, if you were to use, I don't know, Amazon Cloud or Google Cloud or Azure by Microsoft, you still would have full control of your data. Now, this assumption, however, starts to be tricky today. So, for instance, if you think about smartphones, all of you here presume have smartphones. A lot of you will have Apple smartphones. There will be Xiaomi, Vivo, Oppo, Realme, OnePlus. I'm trying to remember advertisements from the Delhi airport and other airports, and there's like this big Vivo thing, okay? But each one of those devices, which are smartphones, have multiple sensors. Now, those sensors generate streams of data. And this data is not processed. It stays there on those devices, but it's privately owned. Then there are sensors and actuators which you can very cheaply buy nowadays. I think that if any one of you wanted to measure quality of air, where are you guys located? Because I didn't check it. I apologize. Where are you located? Anyone? Talk to me.
Pune, sir, Pune, Maharashtra.
Okay. So is air pollution a big problem in your area?
There is a problem, but means there are some areas there are only some problems which are there.
Okay, so think about this. What if everybody who is a student at your university would get herself or himself little air pollution measuring device, which probably would cost nowadays not much. They would be probably below maybe around 1,000, 2,000 rupees, and would put it outside of the window and connect it to the smartphone application. And then suddenly you could have this absolutely fantastic IT project, Students for Air Quality, where you could build models. But each individual stream is not enough. But each individual stream has individual owner. So we don't have one owner of everything. Now we start to see more and more powerful wireless networks. We start to see deployments of 5G. In Poland, we still have 5G over 4G. We don't have real 5G because government is a mess and they didn't announce the auction of bandwidth for 5G. I think that they don't have friends who should win those the auction. So since they don't know who should win, they are not announcing because somebody could win that they don't like. But there is 5G over, there is 3G, 4G, 5G over 4G and 5G. So you can build various infrastructures where you pass information around. There is a lot of research on the Internet of Things. And here, India is a good example. Well, I'm not sure if it is because I haven't been to India. I'm only going to be in India in 2 weeks. So I'm going to start asking questions. But there was this initiative at the beginning of the first time Modi was the prime minister to have 100 smart cities in India. And at the time I was checking it, there were 99 already selected. So look, each one of them is putting Internet of Things ecosystem in place, somehow adjusting it to the local needs, or at least this should have been happening all over India. So there is a lot of knowledge. Now, this means that the vision of a single data owner is no longer valid. You need to deal with the fact that different parts of data that are needed belong to different owners. So, for instance, you have multiple devices and they have data, but this data will be valuable if combined. But how to combine the data if some of this data is private? There may be images, but the images may be locally so many and so large, each one of them, that the idea of transferring them to the cloud from different locations may be tricky. Its name is this way, and I will have an example about this. Now, medical images cannot leave location, at least in Europe. If you are a clinic and you have medical images of your patients, you have to keep them on your server, and you can give a copy on a CD to the patient, but you cannot send them out of your premises. And then situation like this, you have the same kind of data, but it has different owners that don't want to share the data. And we will come back to an example of this in a moment. So how to instantiate artificial intelligence, how to do machine learning if the data is not together in the cloud? This is where the idea of federated learning comes. Federated learning works like this. You train a central shared model. This is a little bit, this can be discussed, but we have only 30 minutes. So if you bring me and my wife to your campus for a couple of days, we can do a course on Internet of Things and artificial intelligence there. But let's say you are training a central shared model. Participating nodes use local data only, and they train their local version of the global model. And then they send suggestions as to how the global model should be updated. The central model is updated based on those suggested updates, and it's redistributed back to participating nodes. So it's like this. Each one of you is training your own little model. You send only updates, not the model itself, and not the data to the central location. Central location somehow averages your suggestions and creates a new shared model, and this model is sent back to you. And the process repeats until an all agreed global model is created. And then it's sent back to everybody saying, hey, this is our common view of the situation. And then you may want to do, if needed, a little bit of personalization, so-called personalization, additional local training. Why you may want to do this? Well, we will have an example of checking for car damages. And here, one of the things that you may think about is that in various areas of India, images of what the dirt on the car looks like may be different. Because if you think about, there may be a situation that there is some cars are dirty, the monsoon way, which means it's mostly water and mud. Some cars may be dry, dirty, like something from Rajasthan, from Jaipur. It's mostly dry, and so it's mostly dust. And then some may be like from Sikkim, they may be mud and snow. So you may want to adapt your model also to the local context. So in general, distributed machine learning is primarily for single data owner. Data is made available, split, and then information is exchanged as needed because you don't have any security, privacy, or trust issues because it all belongs to a single owner. In federated learning, you mostly deal with a situation where you have either multiple data owners or separate locations. Each data can be considered to be private or local, and data is not shared. Data remains private. Where it's stored, it stays there. And only model updates are communicated. And of course, if we deal with multiple data owners, then privacy and trust are of major concern. This is from January 21, the standard taxonomy of federated learning systems, which is into data partitioning, machine learning model. We will not talk more about this, but I will repeat what I already said. Machine learning model can be anything that can be done using distributed machine learning. Anything that can be split will be okay. Privacy mechanisms. What is the communication architecture, scale of federation, and why we federate. Okay, so this is what Lee and associates in the survey from 21 suggested. So let's look at it. Data partitioning. Horizontal versus vertical. Horizontal data partitioning means that you have the same data in various locations. Vertical means that for the same entity, you have data in various locations. So here you have person A, and by the way, here should be person A. Person A is person A, person B, person C, whereas here, person A, then there is additional data about person A. Person C, additional data about person C. Person B, there is no additional data. So vertical data is only here where you have more information about a given person. Privacy mechanisms. You see, as soon as federated learning was created, people started to think, how can we learn about the data if we know only updates? So it is not like we have updates and it's safe. because people can learn about the data just from the update. So things like homomorphic encryption across the system, it will be time consuming, but you only perform calculations on encrypted data. So the data is never decrypted. It costs more, but definitely privacy works. Differential privacy, it is like adding a little bit of noise. And this way, you don't know what the actual data is because you have some dirt in it, and it makes recovering from update much more difficult. Secure aggregation, known story. Scale of federation. You may have cross device. And this is what, by the way, Google is using. It is using billions, gazillions of Android phones and is using sampling to train on your phones and develop various systems, assistants, and so on. Okay. Now here, there is very strong central orchestration. You have a lot of devices that never completed training round, and it is estimated that around 5% of them will never come back to you, but you don't care because you have so many devices that you are fine. Okay. Now, cross silo is something different. It's for more business oriented, business to business. So usually all clients participate in training. You have potentially different topologies, and we will come back to this. And you can have any partitioning, and here reliability is controlled, which means that if this is an agreement between businesses, then devices should not disappear. And if they disappear, this is something that is dealt immediately with. Now, why do we federate? Well, if single owner of data is insufficient, then maybe we need co-petition. Co-petition is situation when you at the same time compete and collaborate. And I will have a comment about this later. And then there may be legal requirements. Data cannot be shared, like GDPR. This is the European General Data Protection Regulation, which tells you that you cannot share data, period, like medical data. So you can build models, but your local data stays local. And then there may be contractual obligations. I am not going to give you my data because it's my intellectual property, and I cannot. Architectures are various because there are special architectures for medical where you are not revealing, you try to be as protective as possible. Standard client server, there are architectures proposed with mediators to deal with some research issues. Application areas. And here is the one which I have an idea for, which is you have preventive maintenance. I hope that you know what preventive maintenance is. It's gathering data and trying to establish when a machine, for instance, may be about to crash. It is now becoming more and more popular when you can put sensors on machines and train the model that would predict, this machine has data that suggests that there may be something going wrong. And in this case, you may want to gracefully stop it and do maintenance check and so on. Here, let's say that you have competing butter producing companies. Okay, in Anand, Gujarat, there is a big butter producing facility that belongs to Amul. You probably all know Amul butter and Amul ice cream and so on. But probably in other places, there may be different companies that are producing butter. But the machines may be coming all from, in Amul, they have, I think, German or Swedish machines. So let's say that you have multiple competing butter producing companies, but they use the same vendor for their machines. Then they will not share the data about how their machines are doing, but they may collaborate, developing better models for preventive maintenance. Pharmaceutical companies, there is an agreement between the big ones, Amgen, Bayer, GlaxoSmithKline, Novartis, that AstraZeneca, that they will be training on private data sets, but they will be using federated learning for drug discovery. There will involved, they are, okay, if it works, because there is now an agreement, there will be this Melody platform, probably running on NVIDIA hardware, okay, maybe using Clara by NVIDIA. So it can be done. Now, research areas, just so you know, it's a very rich area for research. An interesting one is when data is not identically and independently distributed. For instance, you may have a situation where the same, okay, each user writes words similarly, but between users, there are big differences. The same word, different view. Label distribution. Kangaroos are in Australia. There are no kangaroos living in the wild in India. There may be kangaroos in zoos, but if you have images that you use for data training, then data from Australia will have plenty of kangaroos or koalas, whereas from India, you may have, I don't know, apes, you may have elephants, you may have tigers. And by the way, there are no tigers living in Australia in the wild. They are in the zoos. So there is a lot of issues with data sets which locally are very different. And think homes, even within India. If you think about homes in colder areas, Mussoorie, Sikkim, Mussoorie is near Dehradun. It's already colder area. Sikkim, very cold area, combined with houses, homes in Goa. They are very different. And images will be then very different. And you need federated learning, but you don't have a central data set. So it's quite interesting what to do in situations like this. Now, for the project that we are dealing with, we have this maintenance diagnostics. And here you have the idea. I hope that you see those little images. It is like a gate through which a car is passing, and when it's passing, it is taking large number of photographs of the exterior and underneath. So there are cameras here, a number of cameras here, here, and on the top. So as the car is like going through, or like here going through, then you get a complete documentation, 360 degrees, automatic panoramic images. And this is the scanner. This thing that you see here, two versions, is the scanner. Now, what we are supposed to do is automatic inspection based on those images. And here, federated learning is needed because you have multiple inspection stations. They will be doing local processing, and you don't want to send this amount of data to the cloud. It's just not feasible to send all this data to the central cloud. So you have to process it locally. Also, some of those scanners may belong to different companies. If you think about companies at the airports that are car rental companies, different car rental companies have will not release data about their cars. So they can participate in training, federated learning training, but they will not share their data. Now, this brings practical aspects because people who do research usually do research based on central, well, okay, they have the central data set and they fool around preparing various methods of federated learning. But the practice is, here you have heterogeneous clients and networks, which means your federated learning has to deal with delays, interoperability problem, and with stragglers, with those nodes which are weaker, more busy, and they cannot catch up. And the notion of a training ground becomes tricky. If you have weak network connection, there may be interruptions. If you think about India, network connections may be particularly weak because especially in some rural areas of India. And then you may have dropout, results never come. You have to deal with it. You may have very limited resources. There may be local limitations, but there may be even limitations on far edge where you have battery life to deal with. People who do federated learning rarely think about involvement of far edge devices which have limited computing storage and battery life. Okay. Data on local nodes may be redundant, and then you are not training. So large number of nodes has the same data, and then few nodes have different data. And those that are similar may overwhelm the others. Data is not likely to be non-IID. I mean, it's likely to be not good. There will be distributions that you don't want. Topology of learning may be imposed by the structure. It may not be the best topology for federated learning, but this is your topology. Live with it. And oh my God, this should be pre-processing. Sorry, I was preparing pre-processing. Okay. Slideshow, start from current slide. I had to fix it. Data processing. Different nodes can have different data in different formats that need to be adjusted to be able to do common training. All those things that you have on this slide are almost never addressed in the context of published research on federated learning, because research on federated learning is coming from the IT, computer science, computer engineering perspective, and rarely includes the business, the practical business related aspects, the use cases. We have the use case, and we see those materializing as actual problems that we have to deal with. There are platforms, but those platforms are mostly to do research on federated learning, but not to practically employ federated learning in a situation like this one. Generally speaking, those platforms will not help you. We have our own platform. So if anybody is interested in exploring it and developing it, you are invited. So let's summarize, because I ran a little bit over time and I apologize. Federated learning is very important because it deals with real life. It matches the needs of edge computing, computing where data is generated. Can be applied to any machine learning. And here you have archive. This is like more than 100 pages work on federated learning open problems. The practical aspects, oh God, aspects. Sorry, I have to fix it because when I see it, I feel bad. practical aspects of federated learning are an open research area. How to really make it work in practice. And then we, of course, have the federated Sunday FL. Okay, so there is a conference, and by the way, don't look at this part. You can find me not on Facebook. You can email me, and if you do Google Scholar, you can find me. You can find me on LinkedIn. If you want to connect with me, put my name in LinkedIn, but not Facebook, because Facebook, I am overloaded. I already have 5,000 connections, and I will not be able to connect back to you. Whereas on LinkedIn, I will be able to connect back to you. And I would like now to go for a moment here. This is the conference which is coming next year in September in Warsaw, Poland. Conference is called Rank B in Australian ranking. Proceedings are Scopus indexed, so you may want to consider submitting your research and coming to Poland. Okay, and this is the moment when I'm gonna find my Google Meet. I will stop sharing the screen, and I apologize for running over time.
Thank you, Professor Marcin, Paprzycki. That was a wonderful talk. So let me summarize the talk. So basically, this federated learning supports protection of data privacy using the local
I can barely hear you. There is something wrong with your microphone. Okay, where is the chat? Maybe if okay, guys, if anybody has questions,